Hey guys, Mrs. O'Donnell here. Today we are multiplying polynomials again. We're still really focusing on those area models and the box method to help us organize our multiplication. Our goals for today are to use the zero product property to solve and to develop procedural fluency multiplying our polynomials. Again, if you find that you have any questions, please come see me during office hours. I am here to help. All right, so first thing I want to talk to you guys about today is standard form versus factored form. So a polynomial is in factored form when it is written as a product of two factors, right? And you're probably used to thinking of factors like the factors of 30 would be 2 and 15 or 5 and 6. Okay, those would be examples of factor pairs of 30. Well, here we have factor pairs of our polynomials where you just have two things that are being multiplied together to make that standard form polynomial, right? Same thing down here. We have two factors being multiplied together to make this standard form polynomial. So the polynomial is when it's standard form is when it's all multiplied out. Factored form is the two pieces and parts that multiply to make it. And we want to take a minute, go ahead and pause the video, write down what do you see, notice, and wonder about your factored form compared to the graphs that I have shown here that represent each of your polynomials. All right, so hopefully, and maybe you see it more with this bottom factored form here, hopefully you see something pretty cool happening with our roots. Okay, hopefully you see that here we've got this x minus 3, and we've got this root right here at 3, positive 3, and we've got x plus 8, and we've got a root right here at negative 8. Right? So the roots are those opposite signs. Those x-intercepts are where that graph is crossing our x-axis, that parabola is crossing that x-intercept, okay, are those opposite signs. Okay, same thing up here, right? Here it's sort of like we have x plus 0 and x plus 2, right? If you wanted to fill in that factor so it's in that form where you can really see the root. And we see we've got an intercept here at 0 and another intercept, x-intercept here at negative 2. Okay, so something to keep in mind there as we're working through some of these problems. All right, so that brings us to the zero product property. When one side of an equation is a polynomial in factored form and the other side is equal to 0, or the output is 0, you can use the zero product property to solve the polynomial equation. The solution of the polynomial equation are also called roots. All right, so our zero product property is stated as such. If the product of two real numbers is 0, then at least one of the numbers has to be 0, right? So, for example, if I had a times b equals 0, right, then I know either a or b has to be 0, right? Or if I knew a was 5, right, 5 times b equals 0, well, now I know b has to be 0, right? Same thing, if I knew b was 15, now I know a has to be 0, right? Because anything times 0 equals 0, okay? All right, so what does that mean down here? Well, that really helps us figure out our solutions, right, or our x-intercepts. So if I'm looking here, my first factor is going to be equal to 0, and then I can set the second factor equal to 0, so I know, hey, x has to be negative 2. Same thing over here, I've got x minus 3. If I add 3 to both sides, that tells me x could be 3, or x plus 8, right? So that tells me x could be negative 8. Okay, so we can use that zero product property to help us figure out those x-intercepts, or to figure out what number, when you plug it back in, will make the entire problem become 0. All right, so if we graphed these two equations, right, negative x squared plus 4x plus 5, x squared minus 2x minus 5, we could use them to help us figure out what our polynomial is in factored form, right, just by using our roots or our zeros. So this one over here on the left, we could very easily write the factored form x plus 1, x minus 5, and if you don't believe me, right, we can always do that area model, multiply it out and see if it worked, right? X plus 1, x minus 5, x times x is x squared, x times 1 is x times negative 5 is negative 5x, negative 5 times 1 is negative 5. Uh-oh, what did I do wrong? Ooh, there was a negative out in front. So let's see here. What do I want to change? I could try some things. I need that negative 5 to become a positive 5. Oh boy. Well, all right, let's see what we got here. We know we have to multiply our whole thing through by a negative. So we've got x squared minus 4x minus 5, and we know we have the wrong signs all together here. So this whole thing is going to have to get multiplied through by another negative 1. I could switch one of my factors up. So I have like a negative and a positive, negative and a positive. Maybe do that. I don't like how this is working out. But anyways, hopefully you get the gist here. This is not the best example. We are not getting into factoring today. So sorry I went down that road. But the point here with this one, in fact, I'm going to undo sort of that negative that I added in there. Okay, so the point here then, what is more challenging about this equation on the right? Hopefully you see it doesn't actually have nice zeros. They have to do a lot of rounding here. So that makes this problem a bit harder to factor. Okay, so just because you have factors doesn't mean that it will factor nicely per se. Okay, and that's really all I've got for you guys today. Hop on, do this Google form. It's a shorter video for you today. I know I had longer videos for you yesterday. Do your best. If you have questions, please come to my office hours. Thanks so much. Have a great day, and I'll see you tomorrow.